Okay, so now that we've been talking about functions, I want to talk about function operations. Sometimes it's helpful if you have multiple functions to be able to add them, subtract them, multiply, divide, and stuff like that. So let's take an example here. So let's say we have f of x is equal to 2x plus 1, and g of x is equal to 3x minus 5. So some just basic linear functions here. And let's just say that we wanted to run an input through f of x, and we wanted to run the exact same input through g of x, and we wanted to know what would happen if you took the f of x and the g of x and added them together. Okay, so this has a lot of uses in physics, engineering, in the business world as well. So let's say we wanted to do f of x, or not f of x, sorry, f of 4. Let's say we wanted to do f of 4 plus g of 4, okay? There's a quicker way to write this, and so we'll just say, if you'd rather save some time, you can just write f plus g in parentheses of 4. So these two things, namely f of 4 plus g of 4 and f plus g of 4, are saying the exact same thing. So if we were going to actually do that, like if you saw f plus g of 4, you would just do 2 times 4. Let's color code this. So 2 times 4 plus 1. This right here is f of 4. And then you would add 3 times 4, and you'd subtract 5, and this right here would be g of 4. So you would just do that. The rest is just, multiplication and adding. So 8 plus 1 plus 12 minus 5. Let's just do this all together. 8 plus 1 is 9, plus 12 is 21, minus 5 is 16. So f plus g of 4 is 16 in this case. Okay, so this is the basic idea. I'll do a few more examples here. Oh, and then we'll talk about some harder abstract cases. What if I want f minus g of 4? Okay, so this is the exact same thing as f of 4 minus g of 4. So in our case, f of 4 was, remember f of x was 2x plus 1, so it's going to be 2 times 4 plus 1. So that's f of 4 right there. And then we're going to subtract g of 4. So let's write g of 4 right there. G of x, remember, was 3x minus 5, so it'll be 3 times 4 minus 5. It's really important. You don't necessarily have to use these bracket things that I used, but it's really important that you enclose f of 4 in parentheses or brackets or something to indicate that it is its own thing. The reason that that's important is because if you don't put parentheses here, you're going to do 12. You're gonna subtract 12, and then you're gonna subtract 5. But if you think about this, and if you think about the way we distribute things, the minus sign needs to get distributed to the 3 times 4, and it needs to get distributed to the negative 5, which actually makes it plus 5 at the end. So just be really careful when you do these. Make sure, especially if you're doing subtraction, that you close g of 4 in parentheses. Okay, so let's just bring this down here. So 2 times 4 plus 1 is 9, minus, and then I'm going to do what's inside the parentheses here on g of 4 first. So I'm going to do 12 minus 5 is 7. So 9 minus 7 is 2. So f minus g of 4, or f of 4 minus g of 4, same thing, turns out to be 2. Okay? All right. The next one I want to talk about is f times g of 4. So let's do a new page. So if we want to do f times g of 4, this is saying the same thing as f of 4 times g of 4. So remember, f of 4 is going to be 2 times 4 plus 1. So this is f of 4. And we're going to multiply that by g of 4, which was 3 times 4 minus 5. So this is f of 4 times g of 4. 2 times 4 plus 1 is 9. So we're going to have 9 times 7. So this is 63. Now I want to generalize it and talk about, what if we have f plus g of not just a number 4, but f plus g of x. So what if we do that? What if we have f plus g of x? Okay, so I'm just going to rewrite f of x and g of x over here for you. F of x was 2x plus 1. We're still working on those original functions that I gave. G of x was 3x minus 5. Okay, how would you do this? Well, so this is saying the exact same thing. This is saying the exact same thing as f of x plus g of x. So quite literally, all we need to do, if we're going to write this out, is do f of x, which was 2x plus 1, plus g of x, which is 3x minus 5. Your math teacher will, and including myself, will probably ask you to simplify this. So 2x and 3x makes 5x, and then 1 plus negative 5 is like 1 minus 5, which is just negative 4. So this right here would be f of x plus g of x. Or in our shorthand notation, f plus g of x. Okay, well, let's do f minus g of x. And remember, it's really important that you use parentheses on this. So this will be f of x is 2x plus 1 minus g of x, which is 3x minus 5. Before we start subtracting everything here, what I want to do is I want to simplify. So let's do 2x plus 1. That's just going to stay the same. Let's take this negative sign and distribute it to both parts. So when you do that, you get minus 3x. And then if you have a minus sign times negative 5, then you technically have plus 5. So this will be plus 5. Now we can add everything together. If you take the 2x minus the 3x, sometimes I underline like terms just to keep track of everything. 2x minus 3x is negative 1x. I'm just going to put negative x. And then plus 1 plus 5 gives you plus 6. So this right here is f minus g of x. Okay, how about f times g of x? I'm just going to move over here. So what if we did f times g of x? Well, this would just be f of x times g of x, which would be f of x is 2x plus 1, and g of x is 3x minus 5. So we're going to multiply these out. Yes, we're going to have to do the dreaded, many of you refer to this as FOIL. So when you have two, these are called binomials. They're called binomial. Bi means two, and nomial means name. So they have two different things to their name. This one has a 2x and it has a 1, and those can't be combined. You can't just say 2x plus 1 is like 3x or 3 or something like that. We just can't combine those. So those stay separated like that. Same thing over here. 3x minus 5, we can't combine them because they're not what we call like terms. They're not the same thing. If it was 3x minus 5x, you could combine them into negative 2x, but they're different, so we can't combine them. So these are slightly annoying when you get to them because you have to multiply them out. So the easiest way for me to think about multiplying these out, I'm going to color code this for you. So the 2x and the 3x get multiplied first. Then what you're going to do is you're going to take the 2x and the negative 5, and you're going to multiply those two terms together. Basically, each term, so there are two terms here. There's a 2x and a 1. Those are what we call terms. Each term here is going to get each term, T-E-R-M, is going to get a turn, T-U-R-N, multiplying both of the other terms. So the 2x is going to multiply the 3x, then the 2x is going to multiply the negative 5. Then the 2x will be done. Then, from there, we're going to come over and we're going to do 1. 1 is going to get a turn multiplying both 3x and then negative 5. Some people refer to this as FOIL. You may have heard that. Basically, the idea here is that you multiply the first two terms. That's, oh, nope, sorry. That should be in red. So you multiply the first two terms. That's what we've given here in our red. The outer two terms is our green. The inner two terms is what I've drawn in blue. And the last two terms are in yellow here. Okay, so if you've ever heard of FOIL, that's where it comes from. Okay, so let's multiply these out. I'm going to color code these for you. So when you multiply the first two terms, so when you take the 2x and the 3x, you should get, and this is going to be in red here, 6x squared. So those are our first two terms. The next two terms you get, so I'm going to add the next two terms I get when I multiply them together, that's our green, is going to be 2x times negative 5. So 2x times negative 5 is negative 10. That's what happens when we do those. How about the inner two terms? So when I do the 1 times the 3x, that's going to be our blue term. That's just easy. That's 3x. 1 times 3x is 3x. And then we need to add the multiplication of the last two terms, which I've given here in yellow. So 1 times negative 5. That would be our last two terms. So that'll be negative 5. Okay, and what we're going to do here is we're just going to take this little rainbow of math here and simplify it. So if we've got 6x squared, are there any other x squareds in here? I'm going to say no, that's not x squared, that's not x squared, that's not x squared. And I'm going to switch over to white now. So I'm going to have 6x squared. So I've taken care of that. What I want to do now is look for x's in descending orders of power, which is just a fancy way of saying I've done the x squareds. Now I'm going to look for the x's. Now I'm going to look for just the numbers. Okay? Like if I had x to the 5th, then I would do x to the 4, then I would do x to the 3, then I would do x squared, then I would do x, and then I would just do the numbers. Right? So it's just, we call that standard form when you write them in order like that, and we just kind of prefer it that way. So, all right. So we've got 6x squared. What other, do we have any x's? I'm going to say we have just 3x there. So just plus 3x. And then do we have any numbers? We have negative 10 and negative 5. So if we add negative 10 and negative 5, we should get negative 15. Okay? This would be our final answer for f times g of x. Okay? All right, so I want to look at one more example of function operations and then show you a specific case, and then we'll be done here. So f of x equals x squared plus 6. So this is going to be our first function, and then g of x is going to be equal to 2x plus 1. And what I want to do first is, instead of doing like f plus g of 4 or f plus g of 3 or f plus g of 5 or whatever, I want to actually figure out the general formula for f plus g of x. That way, if I ever want to know what f plus g of 2 or 7 or 12 or something is, I actually already have the formula, so I don't have to do f of x by itself, then g of x by itself, and then add them. It's just much more convenient to do it this way. This is how computer programmers think. They're like, well, don't do the specific case for when, you want to do f plus g of 3. Just do f plus g of x in general, then do f plus g of 3 specifically. You save yourself some time. Okay, so what is f plus g of x? So that would be f of x, which is x squared plus 6, plus g of x, which is 2x plus 1. So let's just simplify this. This would be x squared. So I got rid of my x squareds. Now I'm going to get rid of my x's. And now I'm going to get rid of my numbers. So 6 plus 1 is 7. So right here, this is a nice generic, very quick and easy way to figure out, hey, if you ever want to know what f plus g of x is, it's just this. X squared plus 2x plus 7. Okay? We'll hang on to that. What about f minus g of x? Well, this should be f of x, x squared plus 6, minus, don't forget to put in parentheses, g of x, which is 2x plus 1. So this would be x squared plus 6 minus 2x, and then don't forget that minus needs to get distributed to both of those, so it needs to go to that 1 there. So what is this? This is x squared minus 2x and then plus 6 minus 1, so that'll be plus 5. So if you're ever in a pinch and you just need to know real quick, hey, generally what is f of x minus g of x? It's that. Now we can really quickly do things like f plus g of 3. So let's do that. So what if I wanted to know what f plus g of 3 is? You're more than welcome to do f of 3 and then g of 3 separately and figure that out. But we actually already have a function here that tells us how to do f plus g of something. Okay? So all we're going to do is we're going to say that this is equal to our input, which is 3 squared, plus 2 times our input, plus 7, right? So this is the general formula. This is the function. This is the rule. And we're just going to plug in 3 wherever we see an x, right? So it's x squared plus 2x plus 7. Then you can just simplify this. This is pretty quick and easy, right? So this would be 9 plus 6 plus 7, which works out to be, what, 22? Okay, what's f minus g of 3? Well, this would be x squared, and in our case, x is 3. So we're going to do x squared minus 2x, which is 3, and then plus 5. So the math on this becomes pretty quick and easy. 9 minus 6 plus 5. So that's what? 8? Okay, so f minus g of 3 would be 8. The last one I want to talk about is f times g of x, and then f times g of 3 specifically. So let's get a new page here. So f of x we said was x squared plus 6. I'm still using the same f of x and g of x from our last page. G of x is 2x plus 1. So let's figure out, in a general case, what's f times g of x? So what we're going to have to do here is we're going to have to do f of x, which is x squared plus 6, times g of x, which is 2x plus 1. And I'm going to color code this for you again, just so you can see this. So I don't remember what my colors were last time. Sorry if I change them up a little bit. So I'm going to do red first, then green, then blue, then yellow. So when you multiply the x squared times the 2x, you're going to get 2x cubed. That's the red part. The green part is going to be plus x squared, because 1 times x squared is x squared. Then we're going to have the blue part, which is 6 times 2x. That's 12x. And then we will have the yellow part, which is 6 times 1, which is 6. Okay, so this will be altogether 2x cubed plus x squared plus, this is kind of funny, it's not going to really change at all because there are no like terms here. Everything's different. So in general, if you need to know really quickly what f of x times g of x is, or what f times g of x is, it's this. And so if somebody gave you f of x and g of x there and said, hey, what's f times g of 3, you could do this real quick. You would say, well, that's simple. It's just 2 times the input cubed. I'm just following the formula. It's right here. Okay, so we're going to do 2 times the input cubed plus the input squared plus 12 times the input plus 6. So 2 times the input cubed plus the input squared plus 12 times the input plus 6. So this is 2 times, let's see, what's 3 cubed? 3 times 3 times 3 would be 27, plus 3 squared is 9, plus 12 times 3 is 36, plus 6. This is 54 plus 9 plus 36 plus 6. And maybe do this all together in one step. 63 plus 36 is 99 plus 6. I'm getting 105 for all of that. Okay, so that's a nice little trick. So figure it out in general first, and then you can plug in the numbers specifically. I want to talk about one last thing here. And that last thing is, let's come up with a new function here. So I'm going to call f of x, x minus 2. And I'm going to call g of x, 4x. And I want to talk about, you may see something like, hey, what is f of x squared? Versus you might see something like, what's f of x squared? Right? So what I said was the same. I said, what's f of x squared? And then the second time I said, what's f of x squared? So in both cases, I'm saying, what's f of x squared? But I'm just putting the emphasis on whether or not the square comes inside the parentheses or outside the parentheses. So we'll just do both of these for you. So f of x squared is, what we're going to do is we're going to evaluate and say, I'm going to actually color code this for you so you can see this. Let's say we'll put x squared in red here. So f of x squared is taking the f function, or the rule here. What does the rule tell you to do? F is the name, x is the input, and it tells you to take the input and subtract 2. So in our case, all we're going to do on this is take the input. Okay, so f of x squared will be equal to the input minus 2. Okay, that's f of x squared right there. So x squared minus 2 would be your answer. There's not really much you can do with that because we don't know what x is. And we were not asked to evaluate for a certain value. Okay, now what's this other one over here? So this is going to be f of x squared. So what I'm going to do on this one is I'm going to slightly change this and give it to you in green. And I'm going to say we're going to do f of x squared. So what we're going to do now is we're going to take f of x and we're going to put it in parentheses and then square it. So what is f of x? Well, f of x is just x minus 2. That's what the rule tells us to do. Okay, so when we do this, what we have to do is we have to do x minus 2 squared. And remember, if you have x minus 2 squared, don't just say that it's x squared minus 4. You have to actually go through the pain of writing x minus 2 times itself, because that's what it means to square something. And we'll do the FOIL again. So the FOIL says we're going to multiply those two, then we're going to multiply these two, then we're going to multiply these two, and then we're going to multiply these two. Okay, so let's write this out. So this will equal, I'm going to move the screen over a little bit so I can write a little easier on the iPad. When you multiply the red two things together, you're going to get x times x. That's x squared. When you multiply the green things together, you're going to get x times negative 2. So x times negative 2 is negative 2x. I'm going to write that in parentheses. What about the blue terms? When you multiply the blue terms together, what do you get? You get negative 2 times x, which is also negative 2x. And then what do we get on the yellow terms when we multiply the yellow terms together? If you have negative 2 times negative 2, if you have a negative times negative, it gives you a positive. So that's going to be 4 right there. Okay, so let's put this all together. This is going to be x squared. Let's see, we have minus 2x and minus 2x. When you put those together, that gives you minus 4x. And then 4. Okay, so this right here, this long answer, x squared minus 4x plus 4, is f of x squared. So these two things are the same. So if they ask you for f of x squared, that would be this. If they ask you for f of x squared, you would get this answer. Okay, big difference. So let's just do one more example with the g of x here. So what if I had asked you, said, okay, what is g of x squared versus g of x squared? So let's do g of x squared. So what we're going to do is we're going to look at the function g of x. It just says to multiply the input by 4. So quite literally, we're just going to multiply the input, which in our case is x squared, by 4. So that would just be 4 times the input. Okay, so g of x squared is 4x squared. This right here is going to be g of x squared. So let's put g of x in parentheses and square it. What is g of x? G of x is 4x. So if we take 4x and multiply it by itself, that's 4x times 4x, which would be 16x squared. That would be g of x squared.